Today we're going to begin an introductory video for the tools for conservation planning and greenhouse gas mitigation in agriculture and forestry, specifically looking at the COMET Farm and COMET Planner tools. My name is Haley Nagel, and I am an Outreach and Education Specialist at Colorado State University at the Natural Resource Ecology Lab. I work in the research group led by Dr. Keith Paustian. I am presenting today on behalf of my team that is shown on the left side of this slide, and we want to extend a special thanks to NRCS and the Climate Change Office at USDA for their continued support for the development and the use of COMET tools. Additional support and funding comes from a number of smaller state agencies and private donors. A brief history of the tools. So talk about recording and quantifying greenhouse gas emissions began with the Voluntary Greenhouse Gas Reporting Act in 1992 in an effort for farmers and ranchers to have a recording of their greenhouse gas emissions. The IPCC developed these methods in 1997, and for the first time, farmers and ranchers could do just that. The first tools began on Excel and were later upgraded to databases, and in 2006, COMET VR was released and offered a metadata analysis for soil organic carbon stock changes in response to tillage. Later in 2012, an initiative involving the USDA Climate Change Office and NRCS began to take things beyond the IPCC methods for more specific emissions, prompting conversations about understanding the impacts of conservation methods on greenhouse gas balance within agriculture, and seeing the benefit of modifying management practices. What we call the Blue Book Methods document, which you'll see in a few slides, or USDA's Quantifying Greenhouse Gas Fluxes in Agriculture and Forestry, was created in parallel with COMET Farm. So who's using COMET Farm? As of June 10, 2020, more than 13,000 users have created over 24,000 projects using the COMET tools. This includes NRCS field offices, regional conservation districts, farmers and ranchers, education sectors, businesses, scientists, and NGOs. Both the COMET Farm and COMET Planner tools are web-based greenhouse gas inventory tools for land-based systems and are designed for conservation scenario analyses. Users can access these tools through the URLs mentioned on this slide, comet-planner.com and comet-farm.com. The COMET Farm tool is a modeling platform that implements the USDA-sanctioned methods and models mentioned in that Blue Book. In 2017-2018, the Planner tool was created as a simpler tool for regional assessments to visualize general benefits at the regional scale. We will dive deeper into those differences throughout this slide. A brief introduction into greenhouse gas accounting within agriculture. If we focus on the top level of soil within a system, an increase in organic matter by just 1% on 160 acres of soil type of silt loam is the equivalent of about 900 metric tons of CO2 emissions. To put this into context, this is about the same as removing emissions from 190 passenger vehicles for just 1 year, which is about the same emissions as one passenger vehicle driving 2.2 million miles in a year, or removing the emissions related to 100,000 gallons of gasoline consumed. COMET tool is designed to do an entire greenhouse gas inventory within an entity, with a focus on three main greenhouse gases associated with agriculture: carbon dioxide, CO2, methane, CH4, and nitrous oxide, N2O. This infographic was created by a colleague of mine, Amy Swan, as an introduction into the 2007 IPCC assessment. Within the diagram, you can see various sources and sinks of each of these gases indicated by the arrows. For example, livestock plays a critical role in release of methane into the atmosphere through direct emissions from livestock belches and the decomposition of their manure. Methane is also released when growing rice through anoxic decomposition of organic matter in rice paddies. Sources of nitrous oxide include application of synthetic fertilizers and manure decomposition. Carbon also cycles through the soil system either through sequestration or removal from, or loss to the atmosphere. Biotic or living components within an entity also play a key role in carbon cycling through the system through processes such as accumulation of biomass in what is harvested or left as residue, or maintaining living roots within the soil. The diagram demonstrates a simplified version of the elemental cycles within a farm. Each of these sources and subsource emissions are identified in a common balance sheet expressed in a CO2 equivalent as results in COMET Farm. The The COMET Farm tool is a modeling platform that implements more than 40 different USDA-sanctioned methods and models. It implements a set of computer models that simulate all greenhouse gas emissions that have been emitted within a defined entity, from manure to fertilizer application to burning and other management practices. Soil-related emissions are calculated through the DACENT model. Accounting for animal agriculture is also available, and different livestock have different empirical models associated with each of them, as well as forestry and agroforestry systems. The data collected is unique to each individual entity, and to make it as user-friendly as possible, the data is collected comprehensively once and used to drive all the different models necessary. Again, all of these methods are defined in the USDA's Quantifying Greenhouse Gas Fluxes in Agriculture document, which is available for public on USDA's site. To break it down even simpler, the tools are built around a conservation scenario analysis. COMET Farm gives users the ability to input historical management practices and baseline data, so what you would like to compare your new practices to, and then superimposes potential conservation practices to compare the benefits relative to the baseline. While COMET Planner also compares potential conservation practices to a baseline, Planner pulls from regional averages for broad description of conservation benefits. To compare COMET Farm and COMET Planner tools in more detail, COMET Farm allows for flexible farm-to-field specific accounting. Users have the ability to set management practices in an almost infinite number of ways and compare the benefits against the baseline on the same balance sheet. Planner tool is fast, easy to use with only 4 clicks to your results, and a good introduction to determining impacts of conservation practices. COMET Planner tool, however, has a fixed baseline for what is typical farming practices within a given region, and then provides meta-model results of COMET Farm model runs completed at a regional level. These regional averages are developed based on USDA's major land resource areas. The conservation practices are defined by NRCS and include practices that are tied directly to soil greenhouse gas emissions or those that have a biomass impact. COMET Farm tools are a nexus for greenhouse gas mitigation in agriculture, from state to federal level programs and private carbon markets, but also carbon registries and supply chain initiatives using our tools. To dive a little deeper into the COMET Farm tool, the DACENT model, which is outlined in the USDA Blue Book mentioned before, runs simulations about how crops are grown and about how nitrogen and carbon cycle through the soil and ecosystem. The model simulates how crops are harvested, how crop residue decomposes, and how carbon fluctuates between different sources and sinks as a result of physical properties of the soil like temperature and moisture. Information driving these models comes from a dataset developed from peer-reviewed studies from over 200 sites going back 170 years and is maintained by universities and private corporations. An overview of the COMET Farm tool. Some of the common soil conservation practices are simple, but can lead to large carbon benefits. For example, reducing tillage or adding cover crops has cascading impacts on emissions through reducing soil disturbance or maintaining living roots within the soil. Users provide information about specific management practices in their location, and this information is used in combination with historical practices, along with the climate and soil data from PRISM and SERGO. This, combined with the number of USDA methods and equations from the Blue Book mentioned before, drive the DACENT model. This generates outputs which are returned to the user as a result demonstrated in the tabular or graphical report in the right-hand side. First, a user selects the area in question either by drawing the parcel as a polygon of points or adding a plot of land by entering a point and defining the acreage. The yellow lines within the map demonstrate the various map units associated with soil types within the region. Once the location of the entity is selected, the user is asked to describe the historical management practices from before 2000. Then the user describes how they farm the ground now, including crop rotations, fertilizers, irrigation, or any practice that has an impact on the soil, something that stimulates plant growth or soil disturbance. Tillage is going to be one of the most significant for soil disturbances. The drag and drop feature allows users to create a crop rotation with some of the more common crops based on USDA databases on fertilizer use, average crop planting date, and average crop harvest date by that specific region. However, there is a drop-down bar within the tool that also allows the users to select from more than 80 different crops. The user will then implement a future scenario where they can make a simple management change. For example, if reduction in tillage is selected as a management practice, this could lead to less disturbance in the soil, allowing for the soil to stabilize and accumulate more soil carbon. Additionally, more scenarios can be compared if you were to add a different soil management practice. More conservation practices are available depending on what is inputted into the baseline. Then the tool executes the models and allows users to see how their practice changes can impact carbon and nitrogen in their field. While different practices impact different greenhouse gas fluxes, the results are simplified in terms of metric tons of CO2 equivalent. The DECENT model, which is the principal model used to estimate the change in soil organic matter and carbon, allows users to see this change. If you recall back to the system model of greenhouse gas fluxes, indicated in the upper right corner, each category and subsource category on the results page is associated with each arrow. When you extend the greenhouse gas categories into subsource categories, for example N2O, into direct versus indirect sources, a confidence interval is shown around the estimate. Using the Monte Carlo simulation methods, the confidence interval portrayed shows that there is a 90% likelihood that the results fall between the upper and lower bounds, 5% chance that it could be as low as the number on the left, or 5% chance that it could be as high as the number on the right. The COMET Farm API allows for programmatic scripting or a side door entrance to the COMET Farm modeling tool. The API allows for a more extensive regional cropland simulations to be run through the model. It is run through the Google Cloud, and the API utilizes an XML input and output files, which will be shown on the following slides. Use of the API is generally free for limited use and for USDA-sponsored projects. Large analysis requires us to charge a fee to run the API through the cloud, including a licensing fee and a small cost for each COMET model run in this manner. The COMET Farm API inputs viewed on the XML input file will match what users view on the graphical interface. Additionally, the COMET Farm API outputs viewed on the XML output file will also match what users view on the graphical interface. While the API and the graphical user interface are both run through the COMET Farm modeling platform, use of the API is better suited for regional to national level analyses. The API also allows for rapid bulk processing. The graphical user interface, however, is more suited for farm-level analysis and has the ability for quick scenario comparisons. To look deeper into the COMET Planner tool. As mentioned at the beginning, the idea behind the COMET Planner tool was to create a tool that was simple, easy to use, and could demonstrate the relative benefits of the NRCS conservation practices within a given region against the baseline data. For the COMET Planner tool, random cropland and grassland points were identified within each of the approximate 230 different agricultural regions in the country, defined by the NRCS as Major Land Resource Areas, or MLRAs. Crop rotations for each were constructed from the USDA NASS cropland data layer back in 2008 in every region of the country. Additional survey data like average fertilizer rates for crops by state and average crop planting and harvest data for each state were added, thus becoming the baseline for the modeling analysis. On each data point, baseline and conservation scenarios were then modeled in COMET Farm system using soil, weather, and historical management specific to each point and location. The difference in emissions is presented in a tabular report that can be downloaded. The numbers presented in the table are an average of all of those different points within an ecoregion. When you select a county, you are tying the county to a major land resource area. The point-level soil, carbon stock, and greenhouse gas emission changes modeled in COMET Farm were averaged to the regions to provide an average regional impact of conservation practice adoption. The COMET Planner tool generates scenario estimates for 34 NRCS conservation practice standards within the contiguous U.S. and Hawaii. The user begins the COMET Planner tool by entering the location of the entity in question. Each location, by state and county, is tied to the specific data for that major land resource area, and the user identifies the land use associated within the region. The user then selects the conservation practice standard that they would like to superimpose and compare to the baseline. Each conservation practice is subset into various implementation practices. For example, the cover crop standard is broken down into legume or non-legume, and then irrigated or not. The final input step for Planner is recording the acreage for each practice implemented. For each practice, you can enter the same or separate values for the acreage depending on your plan. The results are taken from running the data through COMET Farm. The data presented in COMET Planner are the averages of the data presented from COMET Farm for a given region. Similar to COMET Farm, results are represented as greenhouse gas reductions and CO2 equivalent. Different from COMET Farm, positive results indicate a greenhouse gas reduction or carbon sequestration. Negative results indicate an increase in emissions. For more information on quantification methods and summary of each NRCS conservation practice standards used in Planner, users can refer to the COMET Planner report found at the bottom of the Planner project page. For a tool demonstration, I would like to refer you to the COMET Farm URL, comet-farm.com. Within this site, you can locate the current tutorials under the Help icon in the top right corner. Within this page, you can navigate to several YouTube tutorials that can walk you through demonstration projects using COMET Farm. PDF tutorials are also available, and we will be working this summer to update existing help materials. Upon entering the COMET Farm or Planner site, a pop-up indicating the most recent updates to the tool will be shown. Further updates to come this year include auto-building baseline data through satellite imagery, additional conservation practices, and API improvements. A new help desk ticketing system will also be added to the page to submit inquiries, and webinars for COMET Farm and COMET Planner will be available in the fall. If you would like to request a training for now, you can contact me at haley.nagel@colostate.edu. On behalf of the COMET team, I would like to thank you for your continued support and interest in our tools, and remind you that the URLs to access both the COMET Farm and COMET Planner site are at the bottom. Thank you.